Hello, everyone. Welcome back to SAT Math Question of the Day, where we go over how to do an SAT math question, but more importantly, how to approach it. We have Professor Emeritus Seth Chaiken from University of Albany and his brother Joel Chaiken, and we will start. Okay, so it's a geometry, or actually maybe it's more like a trig question. XY plane, O is the center. You got a measure of x over a radians. That's intimidating. What's the value of a? Oh, well, let's then put this in here, right?
Yeah.
A over this is this. So let's write it in. X pi over a. Okay. Got it.
Yeah.
Aha.
So that's the.
Yeah. So this is like a unit. This is not a unit circle, right? This is not a unit circle. Because
It is.
no, because this distance is. Wait, I always get confused when I left on my
Well,
right.
unit circle means that the radius is 1.
Yeah, but wait.
How
This
do
is
you know the
radical
radius?
3. Wait. Don't rush me. This is radical 3. This is 1. So that means that this thing is the radius.
Yeah.
So the radius, you use the Pythagorean theorem, and you get 3 plus 1. Square root of that is 2. So it is not a unit circle. But we can get the sine and the cosine of that angle, right?
We could.
Yeah, we can get the sine and the cosine. So the sine of that angle is a half. Opposite over hypotenuse, and that's all you need. And frankly, you probably should know going into the SAT that the sine of 30 degrees is equal to a half. It's a really good thing to know. The sine of 30. So this is 30 degrees.
So let's write it down.
So if that's 30 degrees, then what is a?
When you know the sine of 30 degrees equals 1/2, you know that's called the question mark angle.
Right, that's the question mark angle. So pi over a.
You know the question mark angle equals 30 degrees.
Now this is really bad what I wrote here, because now this is really disgusting because you're changing units, right?
Yeah, but really you can say this pi over a radians equals 30 degrees. Right? 30 degrees. That's legal.
A good way to do it. Now, if you're pretty experienced with radians and degrees, you could probably see the answer. I don't see it yet, but
okay, I see it.
Yeah,
I see it. I see it.
Yeah.
Well, what's also important to know is that the angle whose measure in radians is pi. Pi radians is halfway around the circle.
Right. Oh, I see.
Okay, hold on.
I see it.
30 degrees is 1/3 the way around a quarter circle.
You're confusing everyone.
No, that's what I think about. I know that 30 degrees is 1/3 of 90, which is 1/3 the way around the quarter circle. Therefore, 30 degrees is 1/6 the way around the straight angle or half circle, and therefore A equals 6.
Right. Now, many people going into the SAT would already just know, and it took me I said I didn't know, but then I looked at it, I said, oh, of course, yeah, it's 6. Many people would know that 30 degrees is pi over 6, only because they have experience with this within the last year of their classwork.
Yeah.
They would just know that 30 degrees is pi over 6.
Yeah. Well, with my PhD in mathematics,
what?
I don't know that offhand.
I didn't know it offhand. I got intimidated by it when I first looked at this. This A is weird. This A is a weird way to say it. Yeah. Then I looked at it and I said, oh my God, that's just pi over 6.
But I do know that the special triangles used in high school math,
right?
The 45-degree triangle and the 30, 60, 90 triangle. I know that a 45-degree angle is half of a right angle.
Right.
And a 30, 60, 90 triangle, the little angle is a third of a right angle, and the 60-degree angle is twice that.
Right.
Because 30 plus 60 equals 90.
Right.
And so so sometimes I'd also start by thinking that the measure of the right angle is pi over 2 radians.
Right. Yeah.
And then 30 degrees is 1/3 of that number of radians, which gives you a sixth.
That's a great way to think about it. But that does require people to know that pi over 2 is 90 degrees. Which again is probably common knowledge.
The picture. The whole thing about the pi, where all this pi stuff comes from, it goes like this. Here's a circle, right?
Right.
When it's a unit circle, and you have an angle like this, the distance around the circumference.
Yeah, 2 pi r, 2 pi.
No. When you have an angle, here's my angle in red. The distance around the circumference, when you sweep the radius vector through that angle, that distance A measured on the curve is the number of radians of the angle equals A.
Okay.
And then the thing you need to know is that the whole circumference of a circle in terms of the radius is 2 pi times the radius.
Right.
And so all the way around the circle gives you an angle of 2 pi radians.
Right.
Well, to remind people where this is coming from, if instead of the circle being a unit circle, suppose it's a circle whose radius is r, then the distance around the circumference swept through an angle is the radian measure A times r. And so when A equals 2 pi, when this is called, this is A, the angle, when AR, so AR is the distance going around the circumference is 2 pi r.
Right.
We get A equals 2 pi, which means the angle going all the way around and coming back to the start.
I don't know about you, but I was confused by that. But that's okay. Found that explanation a little confusing.
Yeah.
I mean, the whole way around the circle is 360 degrees.
Yeah.
And 300, and then that's equal to the 2 pi. Then there's the 2 pi radians. Is when you have degrees, you can measure angles in 2 different ways: the radians and degrees. Be careful on your calculator. Sometimes you mess yourself up, and your calculator is in radian measure. And then you get the answer wrong, or you measure and calculate in degree measure, you get your answer and got to be really careful. But there are 2 ways to measure angles, in degrees and in radians. And here you have to know how to go from one to the other. But basically, it's good to know. It's really good to know 90 degrees.
Where's it all come from? Well, the year is approximately 360 days.
Right.
And that's the days to go around the Earth. Takes the days it takes the Earth to go around the sun.
Right.
So they define degree measure so that 360 degrees is a full circle.
Is that where they got it from? They did it from astronomy?
I think so. Unless it was due to maybe the Babylonians, who used a base 12 number system.
Right.
For which 360 is a number you could write with zeros.
Right. Okay. So in other words, you don't know.
But the point is, sometime in the past, people got the idea that they could measure angles by dividing the circle into 360 parts.
Right.
Well, there are occasionally, you don't see this in school, but in some engineering applications, they'll divide the angle, they'll divide the circle into hundredths. Have you ever heard of that?
Never.
Okay. But when you use the amount of circumference in proportion to the radius to measure the angle, you're not, it's not an arbitrary unit. It's not an arbitrary unit for how big an angle is.
Yeah, I think we better say goodbye to people.
Okay, so radian measures they use the distance around the circle of a unit circle to measure the whole circle.
Okay.
So 360 is to degrees as 2 pi is to radians, and that's all for today.
Yeah, that's too much for today. That's too much for today. Anyway, I hope everyone got this, but essentially it's a trig question from advanced algebra. Just and we didn't really glossed over it, how important it was to do this. And do you notice how, like, when I was doing it, I didn't really know how I was going to do this. I didn't really know how it was going to turn out. I just followed my intuition, sort of, and just sort of put stuff in that I sort of knew. Right, I played with the problem. I had no idea how I was going to do this.
When you played with it, you discovered that it made use of the 30-60-90 triangle.
Right.
Which is taught in school. So study for the SAT, bone up on your 30-60-90 triangle, and also on your 45-45-90 triangle.
But people know that generally, but what we really want to talk about is the approach.
Why else they go to school?
No, the approach to this stuff. Don't be intimidated by this question. You have no idea how to do it. Just play with it. Write down what you know, and just play with it. And when you play with it, hopefully it'll fall into place. It's so important just to be relaxed, take it easy, and just play with it like I did. And then hope for the best. Usually it works out. And if it doesn't work out, skip the question. Like, only play with it, but don't play with it. Don't spend your whole time playing with it. Just skip it. Okay, so that's probably enough for today.
That's enough for today. We'll say goodbye to everybody.
Yeah, then have a good day. Like us, dislike us, give comments. Oh, I was going to add something else today. If anybody has a SAT math question that they want us to discuss, then email us at satmathquestionoftheday@gmail.com. And we'll check our email every once in a while, and we would love to, do a question that you'd like to go over. Just try to tell us where you got it from. Okay, everyone, have a great day.